The Great Red Spot, which is unquestionably Jupiter's trademark, was once almost 3 times the size of Earth but is now shrinking, which is what is worrying researchers. The spot is a unique phenomenon, and astronomers were eager to learn more about it, so they took the risk and built a probe that would, for the first time, be able to probe the inside of this mystery. Before we begin, we'd like to ask you for a contribution. After the video, your opinion or expertise is very important to us. From now on, your significant contribution will always receive a heart and will be pinned at the top so everyone sees it first. Overseas music. For a long time, we on Earth were unaware of the Great Red Spot, the largest and most significant storm in the solar system, until astronomer Robert Hooke made the discovery. The size and uniqueness of Jupiter, a planet 384 times larger than Earth and likely composed almost entirely of gases, were unknown to people in 1664 when they used a very basic telescope to look into the night sky. In that year, they could only roughly detect a typical stripe pattern, marbling, and the spot. Jupiter is one of the inner planets that is still visible from Earth using basic telescopes. Even to the unaided eye, Jupiter appears to be a bright star in the night sky, yet it shifts positions incredibly quickly. Of course, Jupiter doesn't have any light of its own, but it reflects sunlight in a way that makes it look like a star to us, much like Venus and Mars do. In the late 1970s, Voyager 1 produced the first true color image of Jupiter. Of course, the Great Red Spot was also clearly visible, and researchers gained their first thorough understanding of the composition of Jupiter's surface here. It was discovered that the gas giant's marbling is actually highly dynamic, despite the fact that from Earth it appears that the patterns are constant. Instead, they are massive gas storms and upheavals. It was quickly determined that the Great Red Spot is the solar system's largest storm, the mystery of the Great Red Spot. The Great Red Spot was once 3 times the size of the Earth, but then it shrank over the past 20 to 30 years, and today only one Earth would fit inside. That's certainly gigantic enough. Yet, this process caused researchers some headaches. They didn't know if the storm was a strange anomaly that could almost be called the Jupiter disease, or if this storm could even be important to the balance of the gas giant. Now, you may ask yourself, what is the business of processes on Jupiter? For this, you must know that Jupiter plays a decisive role in the whole solar system. Its own weight stabilizes the orbits of all inner planets, so also the Earth. In addition, scientists say that Jupiter is responsible for keeping thousands of asteroids in the asteroid belt between the gas giants and Mars exactly where they are. If Jupiter's gravitational force fails, or if violent upheavals occur on this planet, this could have repercussions for the entire solar system. Oddly enough, in addition to the loss of size, researchers then observed this from 2008 to 2020. The storm's wind speed increased by 8%. The storm had since shrunk from an oval to a round shape. People speculated whether this compression of the storm could be responsible for the wind speeds increasing again, since we can only view the surface of the Great Red Spot even with the largest telescopes from Earth. It was time to send another probe to Jupiter to study these processes in detail. In 2011, the Juno mission was launched, and 5 years later, the orbiter arrived in Jupiter's orbit. The results of this mission changed everything. We previously thought we knew about the Great Red Spot, what was going on inside the storm. The goals of the Juno expedition were rather clear. In addition to studying the planet's enormous magnetosphere, the probe was to investigate Jupiter's major moons and the large red spot. Naturally, scientists would have liked to send a probe straight into the storm, but due to Jupiter's strong magnetic field, that is not feasible. A lander would likely be destroyed before it had even examined the area halfway. As a result, the scientists had to devise 2 measuring devices that would allow them to finally investigate the mysteries of the patch from a distance. Astronomers and astrophysicists were able to observe how the storm's presence impacts the gravitational field, and, of course, vice versa, according to one study group's examination of gravitational interactions surrounding the storm and over its surface. For the first time, the scientists also noticed how Jupiter's gravitational fields impact the storm and whether they could potentially play a role in its genesis. Over the course of weeks and months, Juno's gravity science instrument collected massive amounts of data, which were then radioed to Earth. By analyzing this measurement data, the researchers were able to determine the storm's origins and, for the first time, document its depth. The second research team focused on microwave scans using Juno's microwave radiometer, which can detect radio signals of various elements and elemental processes on the storm's surface as well as inside, where signatures of ammonia and water in particular were revealed. The radio wave measurements are so fine that researchers were even able to reconstruct that condensation processes of both substances play a significant role within the storm. It soon became evident that the largest storm in the solar system is formed by jets at a depth of 3,000 kilometers, but itself only reaches roughly 500 kilometers deep. The surface is shaped by cyclones and anticyclones. But even though Jupiter appears to be in the same spot every time, moving pictures of the planet's surface clearly demonstrate the amazing volumes of gases and clouds that are present. Storms and bands of clouds cover the whole surface. Naturally, the Great Red Spot, Jupiter's most noticeable storm, is a left turn. Anticyclone. The direction of rotation is not the only difference between cyclones and anticyclones. The temperature distribution in the atmosphere also plays a role in determining the direction of rotation. Perhaps at the location of the Great Red Spot, there is an anomaly in Jupiter's deep layers that causes the storm to turn the other way and be warmer at the bottom. It is also possible that various currents meet on the surface at this location, and due to the immense forces that build up there, an appearance similar to the Great Red Spot is formed. Cyclones are warmer at the top and colder at the bottom, whereas anticyclones are the opposite. Researchers also attempted to explain why the red spot is red in this context. The white, yellowish, or light red stripes on Jupiter's surface are storms or rapidly moving cloud bands, but they are not quite as big or turn differently than the Great Red Spot. The red spot rises several kilometers above the surrounding layers, and the parts of the storm that are rising higher into the atmosphere at this point may react with other gases or elements in the atmosphere. Another theory is that the anticyclone, because of its unusual direction of rotation and intensity, stirs up gases or possibly dust from deeper layers, which then produce the typical red color at the surface. However, researchers are unable to explain this with 100% certainty despite the new discoveries made by the Juno mission. Another tiny red spot appeared in Jupiter's southern hemisphere 2 years ago, indicating to researchers that this type of storm may manifest elsewhere on the planet. Since then, scientists have been examining the Great Red Spot's shrinkage from various angles, even speculating that it might dissolve at this time and that the force is released by a new red storm mass, or even smaller storms could arise elsewhere as a result of the breakup. For a while, the little red spot even moved in the direction of the larger one, suggesting that the two could join. An overview of Juno's mission. The exploration of the red spot is still ongoing, even though in 2021 the probe moved away from the area and took up a new location over Jupiter's south pole. NASA has already provided a brief overview of the Juno mission with regard to the Great Red Spot, stating that the most important finding at present is that the process in Jupiter's atmosphere extend much deeper than originally assumed. Exploring the deeper layers of the gas giant would will undoubtedly be a major concern for the global astronomical community, but it may take years before all the measurement results and images are evaluated, and new surprises may always surface. It is also certain that technological advancement cannot be stopped, and that in a few years we will have even better probes and measuring techniques to better investigate phenomena like the red spot or even gas planets in their entirety. The gas giant Jupiter has already been observed by the new James Webb Space Telescope, which produced this fascinating image. The shading and points of light provide researchers with additional information about the composition of gases, elements, altitude and depth variations, and temperatures on the planet's surface. These new data will undoubtedly advance our knowledge of the Great Red Spot. Jupiter is depicted here using a variety of color filters. Now, tell us your thoughts on this fascinating phenomenon. Did you realize that the Great Red Spot is a storm? What do you think Jupiter's interior looks like? Please share your ideas in the comments below, making sure to like and subscribe to the video. Enjoy your day, and we'll talk again soon.